Hello, my name is Bruce Whitfield. This is Ecen424, Section 1. This is Project 1, the traffic light controller. Project overview, it wanted there's a four-way intersection with a side street. A street runs north-south, B street runs east-west, C street runs southeast. There are 5 lights. The A south light has a yellow and green turn arrow, and then the rest have red, yellow, green. There's a car sensor on C Street. When a car is detected waiting, then as soon as possible, lights will cycle to C Street green and will never be lit up longer than a long time interval. Red and yellow green lights are illuminated for a long time interval. The yellow and green arrow, as well as the yellow lights, are illuminated for a short timer interval. Here's my block diagram. They're all connected. All my components, the timer, LCD display, and finite state machine, are connected in the top level. The finite state machine has a car waiting sensor inputted, and it has a short and long time interval input that is 1 bit that comes from the timer, and the finite state machine outputs a start timer 1 bit into the timer. And then there is a 15-bit output from the finite state machine, which will go to the LEDs on the base 3, which is done through the LCD display. And the LCD display has 2 outputs, an 8-bit JB and 3-bit JC, which are the output buses. Clock, there is a 1-bit clock input into all of these components, and 1-bit reset. Now here is the state machine. I have the entity set up here with clock, reset, long and short time interval, car waiting, input, a start timer output that's 1 bit, and then a message num that's 4 bit for all the 8 different messages that I have, and then a 15-bit output that are the lights that will be inputted into the LCD display. Now here is the architecture. I created a state type. I created signal CSNS of state type. I created 2 temp signals, one for the lights and one for the messages. I have a process with clock and reset in the sensitivity list. If reset's 1, then current state is state 0. If a clock event happens and clock is 1, then current state is next state. My next process has current state, next state, long and short time interval, and car waiting in its sensitivity list. And then I have a case statement with current state as a selector. When in state 0, it starts the timer, and the output, a 15-bit output that goes to LCD display is this. Now, I have technically 17. I would need 17 LEDs to display the 2 turn arrows. So I encoded the A south, and which is the first 3 bits that I'm pointing to right here. I encoded them, so 000 stands for A south green turn arrow green, and then the rest are red. Temp message is 1. If the short time interval has been reached, the next state is state 1. When in state 1, starts the timer, and then there's a 15-bit output, and the first 3 bits are encoded, and that 001 stands for A south yellow, A south green, turn arrow yellow, and the rest are red. The temp message is 2. If the short time interval is reached and a car isn't waiting, the next state is state 2. Else if the short time interval is reached and a car is waiting, the next state is state 3. Now when in state 2, there is an output message. This sets start timer to 1. The temp message is 3, and the temp message will go to the LCD display and let it know what to display. A south green turn green, whatever it may be. And then it's got the 15-bit output, which the first 3 are encoded, and so it is going to be A south green, A north green, and the rest are red. If a long time interval is reached, next state is state 3. When in state 3, starts the timer, and the 15-bit output is encoded in the first 3. 011 stands for A south yellow, A north is yellow and the rest are red. The tip message is 4. If the short time interval is reached and no car is waiting, next state is state 4. If the short time interval has been reached and car is waiting, the next state is state 6. Now, when you are in state 4, the timer enables that, has a 15-bit output. The first 3 are encoded. 100 stands for A south being red, and it actually stands for A south being let me see, it stands for A south being red, and then you have B east, B west green, and the rest are red. Has a tip message of 6. If the long time interval is reached, next state is state 5. And when you're in state 5, it starts the timer, and it has a 15-bit output. 101, the first 3 bits are encoded, and it's A south, yet again, red, and B east, B west is yellow, and the tip message is 6. If the short time interval is reached, next state is state 6. Alright, and now in state 6, you have, it starts the timer, and then you have the C street green, and the rest are red, and the 110 stands for A south green. Tip message is 7. If the long time interval is reached, then the next state is state 7. When in state 7, the start timer is enabled. The 15-bit output 111 stands for A south red, and then C street is yellow and the rest are red. Tip message is 8. If the short time interval is reached, the next state is state 0. And if, when others, in case, and process, set the temp signals to the outputs. And that concludes the state machine. The pitfalls and achievements that I had. The achievements were that the timer and finite state machine for the traffic light controller were fairly simple to code and get working. Setting up the LCD display using the PMOD CLP was initially a pitfall, but understanding how to create the clock divider, creating the constants for the LCD display to differentiate between the display needed for each state, and setting up the process block for the varied displays wasn't easy and proved to be the most challenging. Once I grasped how to pin plan from the JC and JB buses on the base 3, then the LCD display came together pretty quickly. Now, the biggest pitfall I came up to was setting up the top level design, connecting the timer, finite state machine, to LCD display. It was a breeze, but once I started pin planning for the top level, I found that I needed to have the FSM output at 15-bit display so it would go to the LEDs on the base 3, so it could show what the lights were lit up as. This output represents 5 lights, with the 1 light with the green and yellow turn arrow encoded to 3 bits. This output is now the input into the LCD display. The issue I'm having is my timer, simulated in Vivado and Model Sim, both give the intended results as well as the LCD display. What is happening is I connect them all in a top level program, and while the LCD works, the finite state machine and timer seem to be not doing their job. I'm not sure if it's my logic or lack of understanding of how it fits together, but nonetheless, I wasn't able to perfectly finish the project with the time frame given. So basically, I would simulate, and I would simulate in Model Sim. I would set up in Vivado the finite state machine to the base 3. It would work. I would set up the timer in Model Sim and Vivado to the base 3, and it would work. And same thing with the LCD display. Now I can put the LCD display in the top level, and it works. I can put it with the finite state machine, but it doesn't work so correctly, and I don't understand why. I'm not getting the outputs to the LEDs that I want when the finite state machine's hooked up. And then once I hook up the timer up to it all, then I have no display on the LCD, and no lights are being displayed either. So I'm not entirely sure what is going wrong with it, but I'm so close to being finished. I'm just missing a little piece of information that would help it all come together. I did the very best that I could, and I put my time into this project. Individually, I have all my code working, but putting it together in the top level, it's just not having the output that I need. This will conclude my presentation.